Friends, welcome to my YouTube channel. Dhanesh here. Today we are going to discuss about NLP, Natural Language Processing. See, this is the fourth video on NLP. We covered tokenization, introduction, and NLP introduction, and tokenization using NLTK and Keras. Both the aspects we covered. Today we are going to discuss about stemming, another important concept in natural language processing, stemming using NLTK. NLTK stands for Natural Language Toolkit, NLTK. We will discuss about NLTK as well. Let's start. So this is a simple introduction to NLP. This equation NLP is equal to NLU plus NLG. It clearly explains what is NLU, what is NLG. From that you can easily understand NLU and NLG are the subsets of NLP. NLU stands for Natural Language Understanding and NLG stands for Natural Language Generation. NLG is an important part of NLP and NLU, Natural Language Understanding, is responsible for understanding the content and NLG is responsible for generating the content. That's the difference. This is the pictorial representation of NLP, NLG and NLU. See, while building an NLP pipeline, these are all the steps we have to follow. Sentence segmentation and word tokenization, we already discussed. Stemming, we are going to discuss now. Then lemmatization, identifying stop words. Dependency parsing, POS tags. Named entity recognition, NER, and chunking. So these are all the aspects we are going to discuss for building an NLP pipeline. So now we are going to discuss about stemming. See, stemming algorithm, it's a computer algorithm or subroutine that stems words, may be called a stemming program, stemming algorithm or stemmer. It stems word. Stemming is basically removing the suffix from a word and reduce it to its root word. For example, jumping is a word and its suffix is ing. If we remove ing from jumping, then we will get the base word or root word, which is jump. The main aim of stemming is to reduce the inflectional forms of each word into a common base word or root word or stem word. If you are in English grammar, if you are familiar with inflection is a term coming in English grammar. Inflection is a process of word information in which a word is modified to express different grammatical categories such as tense, present tense, past tense, future tense, case, voice, active voice, passive voice, aspect, person, number, gender, mood, animacy, and definiteness. So these are all the concepts behind that algorithm. Now I am just telling about the applications of stemming. What are all the applications? Stemming is used in information retrieval systems like search engines, Google. It is used to determine domain vocabularies in domain analysis. Google search adopted word stemming in 2003. Previously, see, that's what I know. It is another symbol. It's Google search adopted word stemming in 2003. Now, the errors in stemming algorithm, there are two types of errors that usually occur in stemming algorithm. One is overstemming. That is one type of error that can occur. Overstemming is when two words with different stems are stemmed to the same root. This is known as a false positive. Example, universal, university, and universe. All the above three words are stemmed to universe, which is wrong. Which is wrong. It is not correct because university is different. Universal, it's different, but universe, it's not the exact root for all those three words. That is known as overstemming. Another thing error that can occur in the stemming algorithm is understemming. Understemming is when two words that should be stemmed to the same root are not. That is understemming. This is also known as a false negative. Below is the example for the same. For example, these words alumnus, alumni, alumni. So these words, when you do the stemming, you will it can create understemming error. It can create a false negative. See, we are doing NLTK. See, NLTK stands for Natural Language Toolkit. We already discussed. We are using, a stemming is performed by NLTK. It's a leading platform for NLP using Python. NLTK provides libraries for classification, tokenization, stemming, tagging, etc. You can do a pip install NLTK, then you will get NLTK. Pip install NLTK. Then NLTK.download in the Python shell. So you have to do the NLTK.download. This command you need to do the inside the Python shell to download NLTK. It will take some time. When you download NLTK, you will get a window like this. This is the window you are getting. So this window this is the window you are going to get when you do that NLTK.download in the Python shell. In your Jupyter notebook or anywhere you can do that NLTK.download. You will get this window and you can download NLTK. So for tokenization, there are, we already discussed different implementations are there. You can use the, NLTK libraries to, do the implementation for stemming as well. We will discuss in detail those programs as well. So there are different types of stemming algorithms. The most commonly used stemming algorithms are Porter stemmer, Snowball stemmer, and Lancaster stemmer. These are the three most common algorithms we use for stemming. See, Porter stemmer, this is one of the most common and general stemmer. It's fast but not very precise. That is this is the first developed stemming algorithm, Porter stemmer. Next is a snowball stemmer. This the actual name of this stemmer is English stemmer or Porter 2 stemmer. We will call it as English stemmer or Porter 2 stemmer. There were some improvements done in Porter stemmer which made it more precise over large data sets. So it is an advanced version of the Porter stemmer. One can generate its own set of rules for any language. That's why Python NLTK introduced Snowball stemmers that are used to create non-English stemmers. So by using the Snowball stemmer, you can create stemming programs for French or German or any other. See, most of the languages you can use this Snowball stemmer. That's one advantage. This is the last one, Lancaster stemmer. It's a very aggressive stemmer and it is an iterative algorithm. Lancaster stemmer is simple but heavy stemming due to iterations and overstemming may occur. So overstemming is an error we discussed previously. Overstemming causes the stems to be not linguistic or they may have no meaning. So this is about Lancaster stemmer. Now we will get into the program. So this is the Spider IDE. I have Anaconda in my system. I installed in LTK, TensorFlow and Keras and all on top of Anaconda. So when I type a Spider, I will get this IDE. So this is the program I have, written here. So it's, I have imported NLTK from NLTK.stem. I have, import Porter stemmer. This is the first stemmer program, Porter stemmer. Then this is NLTK.tokenize. This, if you are familiar with a word tokenization, so I have imported this word tokenization and sentence tokenization. So this is sentence underscore tokenize will tokenize the sentence, tokenize a paragraph into sentence, and word underscore tokenize will tokenize a sentence into different words. You can understand. See, you can watch the previous video. It's a word tokenization is implemented using NLTK and Keras as well. Both the videos are available. You can see it in the playlist. See, from nltk.stem.snowball, we import snowball stemmer. This is the snowball stemmer. And from nltk.stem, you will import Lancaster stemmer. This is another, the third one I discussed. We imported all these. See, first I am discussing about the Porter stemmer. This is the code for a Porter stemmer. Only up to here it is. This is the code for Porter stemmer. See, I have just put some print statement to differentiate the outputs between different stemming programs. See, first I created a stemmer using the Porter stemmer class. Then I have a list. It contains weighted, weighting, and weights. So how I have a for loop here. So how I am using the stemmer, this object I am using here, stemmer dot stem is the method there. I am passing the this w. I am iterating this list, and that object w is passing here. So let me see. I have another set of sentence here. I have waiting in. I hate waiting in long lines. They waited at the train station. Together. The field marshal looks on and waits for letters. Addressed to him. So this is another sentence. I am again tokenizing that sentence by using the for loop. So I will see what is the output when we use Porter stemmer here. See, let's see it. See what's the output. Let's run this program. So first we will analyze the output for the Porter stemmer. See, this is the Porter stemmer. We can see it in the top. So this is the output for the Porter stemmer. Okay, so first Porter stemmer. See, first thing is wait, weighted, waiting, waits. So all the outputs here are wait. So all the words wait, weighted, waiting, and waits, it is stemmed to the root word, that is wait. That's the output here. We got it. Now the next thing is this thing, right? I hate waiting in long lines. They waited at the train station together. It's a long sentence, and it is also tokenized here. You can see, and it's also stemmed and tokenized. Both the process. See, I hate waiting. It is converted into wait in long lines. They waited. You can see here they waited, but the root word is wait, so they wait. You can see here they wait um, at the train station together. Then what's there? The field marshal looks must be converted into look. The field marshal, we can see here. See, look, it's the root word for looks. It is for looks. Look is the root word. So like this, it will stem the entire sentence. Here it is done the two processes. It has done the tokenization. After that, it has done the stemming process. So this is all about the Porter stemmer. Now I am getting into the snowball stemmer. See, it's the code for snowball stemmer. See, English stemmer, snowball stemmer, English. So I have given, see here you can, for stemming, this is the, I already told in the previous discussion, for different languages you can use different. For example, if you want French instead of English, you can give French. Then it will it will stem the French sentence. You have to give a French sentence there. So English stemmer dot stem having. So having will be converted into, you can see the output here. The output of the, see, this is the output of the snowballs, snowball stemmer. See, from here it is starting. So I just given a print statement so that we can identify the outputs. We can distinguish the outputs of different stemmers. See here, you can see from here the snowball stemmer starting. See, print. See, English stemmer dot stem, it is having. So here we have given this, we didn't give a print, so it's not displaying here. So tokens, you have compute, computer, computed, computing. So what's the output here? All are the outputs are compute. So you have taken inside a for loop and you are printing here. So it is token, this token is converted into computer, everything it is converted into compute. So that's the snowball stemmer. That's what it's doing. Next is the Lancaster stemmer. See, we discussed Lancaster stemmer is the more aggressive one. It's an iterative algorithm. So it's, for example, we created an object of Lancaster stemmer. It is Lancaster. So Lancaster dot stem cats. So it will be, the output will be cat. All right. So trouble and troubling, then troubled, so it is the same trouble you will get. The root word is trouble, but you see, I told you, it is a very aggressive stemmer. See, when I used destabilized, see, it is a very aggressive stemmer. It converted into, it is overstemming. See, dest DAST. That's what we discussed. Lancaster stemmer is a very aggressive stemmer. So it is converted, the destabilized into DAST. It's a overstemming. So that's all about stemming. So the next video we are going to do the stemming with TensorFlow and Keras. We have implemented the tokenization with NLTK. Then another video for TensorFlow and Keras as well. So thanks a lot. That's all about this stemming program. Please like, share, and subscribe. Thanks a lot.